All right, welcome. So in this tutorial, we're going to be going over bit flags and enums to some degree, and why they're useful. So for instance, let's say we're creating an action RPG and you want to convey a lot of information in a small amount of space, like for instance, damage type. What are the problems with that? And we'll go into more detail. But for the TLDR, and what we're going to be covering is we're going to be basically creating an enum that has various damage types, and we're going to be setting those bit flags to give us various damage types, and in fact being able to combine them, which is the real power of bit flags over even just enums, and of course way more than Boolean flags. And then using the comparison operator, the bitwise comparison operators, to both set the flags here and to compare the flags down here. So this tutorial is really for beginners. We're going to go into a lot of depth. We're going to talk about binary and all that stuff. So if you're looking for just a quick and dirty, this is about it, and then we're going to talk about it. So without further ado, let's get into the problem. So let's just say we're making an action RPG and we want different damage types, like for instance fire damage or frost damage or poison or lightning, and maybe we haven't even thought of some of these things that we want to include in our game yet, but we want to have the power and flexibility to add those damage types as necessary without breaking the API. And I'll explain your API and I'll explain what that means. So for instance, let's say this is an enemy character that we have, or the player, for example. And let's say we want to add different damages. So generally we would say we'll create a ready function, and we'll just use that for convenience sake. And then we'll do a take damage. And of course, when you first start out, you're probably just going to take regular damage, right? So you're going to have damage amount, and it'll be passed in as an int. And then you'll have probably some sort of entity health, right? And then you're gonna subtract, right? Entity health minus equals damage amount, right? That's going to be your general how I take damage and calculate it and keep track of it. And then you'll have, of course, all sorts of comparisons when it dies and that kind of stuff. But let's say we want to add things like fire damage, right? Like a damage over time would be fire, and frost might add less damage but add a slow modifier. Poison might be similarly damage over time but faster, or your enemy has resistances to it, so it'll take less damage if there's resistance, right? All those features of an action RPG game. So now we want to add health. And what's the basic way? Well, the basic way you would do this, I think, when you're first starting out, is Boolean flags, right? You would say, all right, well, I need poison, so I'm going to have a var, or fire. Let's start with fire. We're going to have fire, and we'll set that equal to true. Like, we'll start out with fire damage. We're a fire mage, but maybe over time we'll learn frost stuff. But right now it's false, and we don't know lightning yet. Lightning. So let's start with that, right? And so now you want to call this take damage function, and you want to be able to specify whether it's fire damage or frost damage or lightning damage. So the simple way to do that is to just add some flags, some Boolean flags here, right? So we would say fire and frost and lightning, and we'd add that to our function declaration. And then if we wanted to call it, now all of a sudden we have to do this, right? We're going to take damage. And before we were just passing an amount like 5 damage, for example. But now we have to do fire. Now we have to say, okay, well, take damage. Okay, there's 5, and let's say it is fire damage, so that's true. But it's not frost damage, so that's false. And it's not lightning damage, so that's also going to be false. And now we've passed this with the various Boolean flags. And now we can go in here and we can say, well, if fire, then let's do some damage over time we'd have to create a function for that, but let's just assume we've made it. And then if frost, we would do slow. We would slow our enemy down a little bit, or that kind of thing. But you can see how this is going to break very easily the minute we decide, I want poison damage in my game. Okay, well now I got to do var poison. And I'm going to set that equal to false. But to begin with, but now I'm going to say, okay, well now I got to switch my take damage amount, and I've got to pass in poison being true, or poison whatever we've set that to be. Oh, and now we've got to change it here, right? We've got to, now when we call the function, we have to add another parameter. Now, yes, you can use default parameters, but you can see how this is really getting out of hand. And every time we add a new parameter, any place that calls take damage, anywhere in your code that has take damage, we have to start accounting for this extra variable. And God help you if you add another variable, now you've got to go through the whole thing again. And each time you do that, you increase the risk of code breaking and all that stuff. So how do we kind of convey information in a more condensed format so that we don't have to keep breaking our API? And the first answer to that is an enum. So you can imagine, okay, well, we've got this problem. So what's the next step we could do? Well, we could do a damage type, right? We could do a damage type, and we could make it a form of an int, right? And we could kind of keep in our head, a code, right? Like 0 is no damage modification. 1 is fire. 2 is frost. 3 is lightning. 4 is poison, right? We'd have to keep that in our head. But at least, hey, now we've got this kind of convenient code. And we can just say, okay, well, let's see, this guy has fire damage or frost, or was it lightning? Okay, we'll put 3 in there, and now here in our function API, we at least don't have to keep changing things, right? If we have damage type, which is an int, we can say, okay, well, if damage type equals 3, now it's lightning damage, but the power in this is we can add a damage type without breaking our API. Anytime we call take damage, we just need to know the code. But of course, this is tedious, right? And you're easily going to end up with these magic numbers everywhere, and you're going to forget, okay, wait, is 6 fire? I'm going to look at my little cheat sheet here. That's not a great solution. But fortunately, programming languages have solved this. And instead of you keeping track, you can label these integer codes, and you don't even have to know which ones they are. And that is the power of the enum. So let's talk about enums really quickly, because we're going to use them later too. So, and then we'll see what the shortcoming of this enum is. So now we're going to call an enum, and you can name them, and I think it's probably best practice to just name them so that you don't end up littering your namespace with magic capitalized variables. But we can now say, okay, well, we've got this damage type, and we just put in these curly brackets, and then we start labeling things, right? We can say none, no modifier. We can say fire. We can say frost. We can say lightning. We can say poison. And we can come back later and add something if we want to. Nothing limiting us. So now we've got labels for these. And under the hood, there is nothing special about these. Each of these is going to be assigned a number. So for instance, none is by default is going to be equal to 0, fire is going to be equal to 1, and it just goes in the order of this list. This is going to be 2, this is going to equal 3. Now you can assign them if you want to. I'm not going to get into that, but you can just put equal signs and assign your own codes if you would like. But basically, if you don't specify anything, it's just going to start at 0 and go. Now, but the good news is you don't have to remember. You don't have to remember this. You can just put in the name. So I'll show you what I mean. Now, under take damage, instead of, let's get rid of this damage type here. Now, when I take damage and call the take damage function, instead of this, I can pass it the damage type. And I can specify damage type dot none. So now I'm going to call this function without any damage type, and let's get rid of this. So now instead of calling if damage type equals 3, and since it's an enum, it is basically an integer under the hood. You can even, for example, label it and keep it of type int, and it's going to work just fine. So here we have damage type none. But let's say I want to, and then for down here, we're going to start comparing them. So we can start to say, well, if damage type equals damage type none, then, pass. But if damage type equals damage type dot, and so it's, that is wrong here. This is the problem with keeping things the same name, but damage type equals damage dot fire. Now we're going to call our damage over time function. Okay, and you can imagine we're just going to go through that list, right? If damage type equals damage type dot frost, add the slow, poison, add a different damage over time, calculate resistances, you name it. But you can also see I can just add another damage type. Let's call it like frostfire damage, right? So now it both adds the damage over time, but also partially slows it. Maybe each one not quite as much as the other, as each individually, but you can imagine that would be something. And now we don't have a breaking API, right? I can just come in here, and I don't have to change all my take damage functions everywhere, and add extra strings of false and true and all this stuff. I can just come in here and say, okay, well now look, I'm just going to pass in frostfire damage, and then all I have to do is add another check here. If damage type equals damage type dot frostfire, now I can do that special calculation. But as you can see, there is a limitation here, right? And what is that limitation? Well, the limitation is you can't combine these things. You can't combine frostfire and lightning. Like, let's say you have, both damage types on your character, and you do 14% lightning damage and 60, right? I would have to add each one of those, like frost, fire, lightning, right? And I would have to kind of add those things together to start adding these combination effects. And this is where bit flags come into play, and why they're very powerful for conveying a lot of information that won't break your API every time you want to use it. And we're going to look and see how we can do that. But especially if you're a beginner, which this is aimed at, you might not have encountered. Why do I have device manager? You might not have encountered bits, and so let's just talk about them very quickly. It's not going to be in depth. There's a lot of good tutorials on bits and how computers store it, but I'm just going to give the quick and dirty. So the way computers store data is in zeros and ones. I think pretty much everybody knows that, right? So, text cubes, that's supposed to be a 0, but let's make that a little better. And it's just sequences of ones and zeros that equal the code, right? And that's how ASCII is, like, for instance, different number codes will work. And remember, this is all binary notation. So this is, 2 to the powers, right? 2 to the power n is going to be each of these bits. And what do I mean by that? So for instance, if you have the number 0, well, that's easy. That's just going to be represented in binary as 0. And 1, well, that's easy. 1 is just going to be represented as 1. But where it starts getting a little more complicated is what happens when you need the number 2. Well, the number 2 is, we can't just store it as 0 as 1. We ran out of on and off bits. So now we need a second bit. So now you're going to have a 2-bit number is going to be needed to store the number 2. And in this case, we started out with 0 and 1, so now we need a second bit, and that we're going to turn on to be 0. turn on to be 1, and then the next one is going to be 0. So 2 is the same as 1, 0. And if you can imagine, well, how do we represent the number 3? If you think about it, well, we don't need another bit because we've got one more thing we can do, right? We can do 1 and then turn this other bit on. 1 and 1. We can't really do 0 and 1 because that's 0 and 1 is just the same as 1. But with 2 bits, we can now represent the number 3. We've run into a problem again. What if we need the number 4? Well, if we need the number 4, we unfortunately are going to need another bit. We've run out of bits. So in this case, 4, we can put in one more bit, and now we can do 0 and 0. And that's the number 4. And you can imagine it's just going to go like this, and I'm not going to do this too much, but you can imagine 5. We already have those other bits, so we can do 1, 0, and 1. 6, we can do 1, and then this is already 1, but we can turn this one on, and we can turn this one off. Great. And then 7, now we can use that last one, turn that one on, and you can imagine we can go through this, and then of course 8 will just be one more. So 1, 0, 0, 0. And if you do the math, you can see that this is the 2 to the 0th place, right? So 2 to the 0th place can hold both of those. 2 to the 1st place would be this bit right here. And then plus 2 to the 0th place is these guys. So it's going to be, this one is going to be 2 to the 1 times 1 plus 2 to the 0th times 0 since it's off. And what does that equal? Well, 2 to the 1st is 2 times 1 is 1 plus 2 to the 0th times 0 is going to be 0. So that's going to be 1 plus 0, which equals 1. Well, which equals 2, since 2 to the 1st is 2. And then 3, you can see here how this would work. This is going to be 2 to the 1st is 2, plus 2 to the 0th, which is 1, times 1 equals 1. So 2 plus 1 is 3. And here we have the same 2 to the 3rd power now, times 1, plus 2 to the 2nd power, times 0. I got ahead of myself. 2 to the 2nd, times 1, 2 to the 1st times 0, plus 2 to the 0th times 0, right? And so this is 4 times 1 plus 2 times 0 plus 2 times 0 is 4. And you can kind of go through that. And we're actually not going to need to know too much about all that. But what we do need to keep track of is the places. And I'll show you why that's important. All right. So the basic idea of bit flags, and I'll show you where at the end where Godot already uses this, and you might have already, if you've done some tutorials about collision, you've already seen where bit masking is used in the engine. All right, so here's where bit masking comes into play. So as we can see, we already know, right, that each bit can hold a place. 0, 0, 1, 0, 1. And it's important to remember integers in Godot are stored as 32-bit integers, which means that they have 32 of these spaces in memory available. And I'm not going to draw them all out because that will get tedious. But you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I have to 16. So basically I have to just double this in terms of numbers, and we'll have a 32-bit integer, which, as you can imagine, can hold a decent amount of numbers. In fact, up to around 2 million signed and 4 million unsigned. But what is important about this is we know all the places. Okay, So, for instance, in a 32-bit integer, let's assume that the numbers are going this way. So we could start out, this is the 2 to the 0th place, and this is the 2 to the 1st place, and this is the 2 to the 2nd place, and this guy is the 2 to the 3rd place, and this guy is the 2 to the 4th place. So hopefully you're with me so far. Well, if you look at this, this actually conveys a lot of information. We can actually use the idea of knowing which place this is to hold up to 32 units of information. And I'll tell you what what this means is that we can say, and we can assign each portion of this integer a value. So we can say, hey, 2 to the 0th place, or the first bit, this is going to convey whether we have a modifier, for example. Let's just say do we even have a modifier? If we don't, why bother checking all the rest? Why even go through all those if statements if it's completely unmodified? And this first one, we can say, we can assign this to be the fire spot. And the third place here, we can assign this to be the frost spot. And this spot we can assign to be the lightning spot. Now that we've assigned these spots, and I'll show you how we're going to do that, now that we've assigned these spots, you can imagine what is the power of this, right? Now we can convey a lot of information using one variable. In fact, we can have multiple things set per variable. We can set for instance, we can have this unit, now that we know that it's lightning, frost, we can say, yes, it's modified, and no, it doesn't have fire, but yes, it has frost, and yes, it has lightning. And we pass this information to our function, and now we just have to decode it. That's going to be the slightly trickier part, is now we just have to decode what do each of these places mean. And as long as we can do that, we can now check for both frost and fire, and frost fire, for example. We can say, okay, is this one on or off, or is this one on or off? And if both of these are on, then we've got frost fire. If otherwise, we've got just frost or fire or lightning. And we can easily start to just assign further bits. We can just say this one is going to be poison. And as we decide more and more damage types, we can just keep assigning these bits different things. So how do we do that? And the answer is we're going to use these bitwise operators. So the first thing to do is realize, okay, well, how do we compare these two things? Well, we need a known thing, right? So we can say, for example, let's just use 8 bits because that's, I think, so. But as you can imagine, you can actually store up to 32 information tags with this, which is, quite a lot. Oh, I've turned blurry for some reason. Hello, NVIDIA. Okay, there we go. So how do we do that? Well, let's just take a few examples. Let's just do 1, 1, 0, 1. So this is going to be our whether or not we even have a modifier. This is going to be fire, frost, lightning, and poison. And we know that this is the 2 to the 0th, this is 2 to the 1st, 2 to the 2nd, 2 to the 3rd, and 2 to the 4th. So we can say, okay, well, frost, or sorry, this is a bad example. Let's start in order. So we can say, all right, we can say int, right? We have an int, and we'll call it, I might keep doing that, modified. And we can set it equal to 2 to the 0th, which is going to be 1. Okay, so that's that place. And then we can set another variable, int fire. And that's going to be 2 to the first, which is, of course, 2. And then we can set frost, which is 4, right? 2 to the second power is 4. And we can set lightning to equal 2 to the third, which is 8. And poison. I think you're starting to get the pattern. 2 to the fourth, which is 8 times 2, which is 16. And you can see we can just keep going, right? If we want to add another damage, we just have to take the next power of 2. Int, let's say, I don't know, spike or earthquake or something like that, spike damage. Now we just 16 times 2. Now we just set that 32, which is 2 to the fifth. So remember, this is 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5. Now, how do we actually use this information? Well, this is where these bitwise comparison operators come in. So, let's say we want to check the incoming variable. Let's say and I'll show you how to set them, but let's first figure out how we can compare them. We know that this variable coming in is 1, so it has a mod, no fire, frost, lightning, poison. And we know that each of these is actually going to be represented by these things too, right? 0, 0, 0, 1, 0, excuse me, 0, 1, and this is going to be 0, 0, 0, 1, 0. This is going to equal 0, 0, 1, 0, 0, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, and this one's going to equal 1, 0, 0, 0, 0. And you can see this is going to get a little tedious, and I'll show you how we can use enums to make our lives a lot simpler in a second. But first we have to understand it. And so now we're at this idea of the bitwise comparison. So we need to compare this incoming variable, right? This is going to be a variable, so it could be anything. This is the variable. And the incoming variable, which is what we're setting our damage to, is 0, 1, 1, 0, 1. So how do we compare to see if this one is on or off? How do we know that? And we compare it to these known values. So we have to say, if these two are the same, if this one, this bit, and this bit are the same, then we know that there is in fact a modifier coming our way. And then we need to check, hey, so if this is fire, well, how do we do that? We have to say if this second bit is set, which it's not. So if 0, so now we need this one to return a false, right? Because we know that the fire has this second bit set, but this one is not set, right? This one is 0. So if this is 0, we need this one to return true, and we need this one to the second one, 0, 1, 1, 0, 1. When it compares this bit to that bit, we need it to equal false. And by now, obviously one of the prerequisites is kind of understanding Boolean comparisons, right? Oh my goodness, NVIDIA, sorry. Focus. So we know that we need some way of comparing these to say, like, okay, if this modifier equals the first bit, then return true. Then this needs to return true. And then we need to say if this fire bit is not set, which is going to return false, right? Because it's not equal to 1. It does not equal our fire bit because it's 0. Now we need this second bit to return false. And this is where the Boolean comparison operators, the bitwise comparison operators, come into play. And in C or C++, you might know that the Boolean operators and or it uses this symbol for the and this symbol for the or. Well, it turns out that just a single character is the bitwise operator, and that's true in Godot too. So the way we compare each bit by bit is using these bitwise operators. So we can do this. We can say if the variable or the damage type coming in and mod, meaning this is going to look at this bit and it's going to compare it just to this bit here, this first bit here. If these two types, when they are compared just based on the bit that's set, is true, and it'll return either a 1 or a 0. In this case, it's going to return a 1 because, or actually, really, it's going to mask these two. So it's going to go through 1 by 1 and set these. And what do I mean by that? So when you go by bitwise, what this does is it takes the damage type, which I think we put 1, 0, 1, 1, 0, 1, and then it stacks it up with this our mod, and the mod is 0, 0, 0, 0, 1. Okay? So now what it does is it's going to compare these two. Okay? So what it's going to do is it's going to look at this one and it's going to say bit by bit. This one is going to return a 1 because 1 and 1 is 1. But with the and modifier, 0 and 0 is 0 because it's 0. 1 and 0 is 0 because, again, just like the and modifier, if one is true but the other is false, you're going to get a false. And same with this one. And same with this one. So now we've got a result that returns as 1. And it turns out that 1, anything that's not 0, anything that's not 0 is true. And so when we look at the damage type and we do a bit flag, we'll get a Boolean, or we'll get an integer that is set to 1. And 1 is not 0, and therefore it is true. So if we do this if damage type and mod, we're going to get 1. Let's look at some of the other ones, because I know it can be a little bit confusing to start out with, to wrap your head around. So let's go with the next one. So now we know that fire damage is 0, 0, 0, 1, 0. So, for instance, let's do 0. This is fire damage, right? Yeah, so 0, 1, 1, 0. 1 is our variable, and then our flag that we know the known value is 0, 0, 0, 1, 0. So this is our fire, and this is our variable that's coming in. Now, when we do a bitwise and comparison, so we do if damage type and fire, well, let's compare and let's see if this is going to be true or false. So let's see. Well, we know all of these flags are set to 0. So when you do a bitwise and, all of these bits are automatically just quickly set to 0. 0, 0, and this is going to be 0 because this is the only one that's going to matter, and it's going to matter depending on what our initial variable is set to. So because our fire is 1, but the variable coming in is 0, when we do the AND, this gets set to 0. So if damage and fire, that's a false. So we do not have fire damage set on this. And let's say the incoming variable is frost. Well, again, 0, 1, 1, 0, 1, and the frost is 0, 0, 1, 0, 0. Well, we're just going to cross out all these when we do the AND operator. So the only flag that's going to matter when we do the comparison is this guy. And since this is 1 and this is 1, the AND operator returns true. So as you can see, as long as we can set up ahead of time these masks, and these are called bit masks, and we know, and we assign them to some sort of term that we can remember. If mod is 1, 2 is fire, 4 is frost, 8 is lightning, 16 is poison, then anytime we do the incoming damage type and compare it to the fire type, we suddenly have this ability to do these Boolean comparisons, and we can now look and see, hey, this variable has the fire damage set, this one has frost, and you can imagine we can just keep adding ones to this without having to deal with much else. Spike is 32, and I don't know what other damage type is there. Nuclear is 64, and so we can just set those flags and set those variables. Now, how do we set flags, right? So how do we determine when we're passing in these this damage type? How do we account for that? How do we set these variables? And that is where the other bitwise operator comes into play. Let me see if I can paint on this. Okay, so that's where so if you remember from C or C++, this is the Boolean OR operator. Well, if you just take one of these, and these are the pipe symbols, so on an American keyboard anyway, it's Shift plus the / key, at least on my layout, and that's that pipe symbol. This is not a 1, this is the pipe symbol. I should have done that for 1, so I apologize this whole time. But this is the pipe symbol, and I'll try and do that next time for 1s. The pipe symbol is the Boolean, is the bitwise OR operator. So now what we can do is, OR is really powerful, right? Because OR, instead of demanding that both bits in both places are set to the exact same, now we can actually start creating our own set of masks, right? So we can say, okay, let's take, I want to have, I know that it's got a modifier, and I want it to have frost damage, and I want it to have poison damage, okay? So, I think poison damage. So when I call the function with the damage type, to construct the variable that has these flags set, to make this guy, I combine these terms of these known values. So I know the modifier is 1, so I can do this. I can do mod, and then I use the OR operator, and what that's doing under the hood is we got 0, 0, 0. Let's see, 1, 2, 3, 4, 5. Right, that's this mod one. I want to have it have fire damage, so I'm going to use mod or fire. So this is going to be 0, 0, 0, 1, 0, and I'm going to have it have, let's say, poison damage, and that was 1, 0, 0, 0, 0, and so I do mod poison. So when I use this OR operator, it combines these bits together in place. So what this is going to end up looking like is the first bit is going to be 1. The second bit, well, that's 0, and that's 0, so that's 0. The third bit is 0, 0, and 0. So that's, and so that's 0. The fourth bit, though, That's this fire. Well, 0 or 1 is 1. Or 0 is still 1, right? Because this at least is, if any one of them is set to 1, then using the or operator, all of them become true. So we know that this is going to be set to 1. And similarly, the last variable, which is the 5th bit, this is 1, this is 0, this is 0, but it's okay because as long as one of them is 1 and we use the or operator, now we can do that. So now we've constructed our own unique variable that has a modifier flag set, the fire set, and the poison set. It does not have frost set, right? Frost is the 3rd digit, right? So that's 1, 2, 3. So that's this digit. It's not. So when we come to the variable and compare it, right, and we say our incoming variable is 1, 0, 0, 1, 1, and we do the and comparison to frost. Well, frost, right, was 0, 0, 1, 0, 0. So it's going to compare. Well, 0 and 1 is 0. 0 and 1 is 0. 0 over here and 1 is 0. 0 and 0 is 0. But 1, which is our known frost variable, right? 2 to the 2nd power. Right. Remember, this is 2 to the 0th, 2 to the 1st power, and then this bit right here is 2 to the 2nd power, which is 4. Well, 1 and 0 is 0. So this is going to be false. And so if we do if, damage type and frost, that's going to equal 0. And it's going to be false. And this is going to skip this if statement, right? Because it's false. So, that's great, but of course it is a little tedious kind of going through these one by one, and that's where, and trying to remember, you litter your namespace with these things, and that's where combining this with an enum really comes into play. And you can do this one of 2 ways, and I'll show you the first way, which you might see in other people's code. You declare an enum, damage type, right? And you put your curly braces, and now you can say, okay, modifier equals 0, and usually these are capitalized, right, in enum, so we'll do that. Mod equals 0, fire equals 2, frost equals 4, etc., etc. But if you don't want to remember it and you want to just kind of look at the flags, you can actually use bit literals. So instead of doing that, you can say mod equals 0 b. So this is 0 b. And if you want, you can put some leading zeros. You don't have to, but let's just do that. 1, 2, 3, 4, 5. And then you can set fire equal 0 b. And this way you kind of keep track and you don't have to remember all the powers of 2, right? You can just be like, okay, well, fire is 0, 0, 0, 1, 0. And frost, I'm going to assign to 0, b, 0, 0, 1, 0, 0. I think that's right, yeah. 0, 0, 1, 0, 0. And so on and so forth. I'm not going to go through the whole thing. But as you can see, this is a really convenient way of creating different variables. And now when we go back to our original project, which I showed you at the beginning, so let's go to finished. Now you can see how we can combine these. So in our take damage function, we have our damage type, and we can have none. set, and that way we can know, okay, well there's nothing coming, so we can say and frost is going to be oh, see, I did this poorly. Okay, none. So let's do, I did this exactly differently, so let's just do this together. Fire, or let's call this the modifier rather than none. Fire equals 0, and we'll just do 5. But remember, you have up to 32. You can really go to town with this, and you don't have to add all the leading zeros. So you can really kind of keep it a little more easy to read at the beginning. But the mod is going to be 0, 0, 0, 0, 1, and fire is going to be 0b 0, 0, 0, 1, 0, and frost is going to equal 0b 0, 0, 1, 0, 0. And again, you can put these as 1, 2, 4, 8, 8, 32, all that stuff. So sorry, 2, 4, 8 would be the same as this, right? So this is the same as 8. Frost, and then what did I say? Lightning, 0b 0, 1, 0, 0, 0, and poison equals 0b 1, 0, 0, 0, 0. Now the trailing zeros are important, but the leading zeros are not. I think that's right. 1, 2, 3, 4, 5, and then we got to close it off with a bracket. So now we've got our bitwise enumeration, and we can use this very simply. When we call take damage, we can give it the amount, right? And we can say, okay, I want damage type. Well, first of all, I have to set the mod, right? Because I know that I want the mod. And we're going to use the OR operator. That's going to set that first bit in our variable. That lets us know, hey, there's a modifier coming. Damage type dot fire and damage type dot frost. And when I keep saying and, but what I really mean is bitwise OR. And what these are doing is these are combining together to create this this binary, this bitwise thing. And we can actually print that out. Let me see if I can do this. So print, and I think it's string dot num int 64, and we can pass our number, which is the damage type. And I believe we use base, and the base is 2, right, because we're in binary notation. So we can print out the damage that's coming in. And so this is going to be fire and frost, and I told you we can use the first mod to skip everything, so we can indent all these, and we can put what's happening? If damage type, if damage type and, right, because now we're going to actually compare, is that bit set? Damage type and our damage type dot mod using our thing. So if these two are the same, right? If we've got a modifier, then we can say, hey, we'll print run through the if statements. So I'll do mod detected. Run through the if statements. All right, and let's just cancel this out for a second. Okay, so now we're going to be looking at what's coming in and what the damage type is, and we can actually print the mod too. String dot num64 int damage. We can actually put damage type dot mod base 2, and then we could say a mod detected. Okay, so let's start with that, and we can hit print, or we can hit play. We can hit play. can save this. And hello, Godot. I don't know why that's not working, so let's just close it and reopen it. And hit play. Good old Godot. And as you can see, we have this variable down here that has taken fire and frost, and the modifier is set. And of course, this one is our frost damage, but of course, which is set at 1, which is the modifier. So we're printing out the mod. And of course, we can print out a few of the other ones, right? String.num in 64 damage type dot fire to image dial and you can see down here mod is detected, but our fire damage is 0 and 1, whereas this unfortunately is not printed correctly, and I don't really feel like formatting the string, but you can see that the mod is detected. But let's say we don't set the mod flag. Okay, let's just delete that flag. We're just going to set fire and frost. Well, the mod is not detected, so it doesn't print. This statement here is false. And you can see how we can just construct the stuff. So we will include our modifier that's just going to short circuit things if we don't have one. Damage type dot mod, and we're going to set damage type dot fire and damage type dot frost. And meanwhile, we haven't even set those lightning and other stuff, but those are all those bits are going to be 0 by default, because we know that all of those bits are preset to be 0. The only one that is set is this fire. So we can now start going through these if statements. If damage type and damage type dot fire. So little damage type, that's our little damage type, remember, is the variable coming in, and this is our known enum. If these two are the same, like if that bit is set, then we can print fire damage. And then if damage type and damage type dot frost, print frost damage. But here's what's really cool, right? If we want to see if both of those are set to see Frostfire, there's a couple ways we can do that. The probably the more straightforward way is you can say if damage type and damage. Okay, I'm just going to use copy and paste because I don't have the energy. If this and this, print Frostfire damage. And now, if we hit play, you'll see we've got mod detected, so we're going to run through the if statements. Fire damage, frost damage, and since both of those flags are set, we have Frostfire damage. Now, of course, you might want to have a specific Frostfire if it's going to do something completely different, but there you have it. And for instance, we can easily just add additional lightning damage. Damage. So first we need a condition, right? And take damage type dot lightning. Now print additional lightning damage taken. And all we have to do up here is when we're setting our damage, we can do damage type. We just add another or bitwise operator to add another term, lightning. And when we run our game and we pass that in, now we have additional lightning damage taken. So I think this is where these things become helpful, is you are really leveraging the power of these Boolean flags to pass in a lot of data, in fact, sometimes combine data, in order to pass in more information in a much more compact form. And you give yourself a lot more flexibility. And as long as you use like things like enums to help you out, you can now utilize the power of both the English language or whatever language you're using this in, and these Boolean flags. And I did promise you. Okay, sorry. One other thing is, so technically, you don't need to use these double comparisons. You can do. I'm just going to get rid of this. You can continue to use the Boolean operators, right? If damage type, and remember, we can just combine these terms, fire or frost. So just to kind of show you, this is basically how you'll generally see these going. What this means is I want to create this type, which is going to be fire or frost. And if this damage type has both of these set, right? Because now when you do the and comparison, it has to be true for both fire and frost. Then it's going to print the frost fire damage. And so there you have it. Frost fire damage returns true. So you kind of are basically constructing your own little comparison, and then all of the bits set here have to be the same as this thing you've constructed here, if that makes sense. If it doesn't, I'll try and explain in the comments a little bit more. But I did also promise you where you've already seen bit flags. And the answer to that is, let's create a new node. Let's call it an area 2D. And if you look at the area 2D under collision, which I'm sure you've done, here you have it. Look at that, 32. The mask, 32. So the Godot collision engine is using bit masking to do that. And when you call it layer 1, you can rename it. This is just creating a name in an enum for you. Let's call this player layer, right? So let's say the player's on the player layer, and the enemy you might want to create on an enemy layer, and it's going to look for the player layer. What is it doing? It's just doing, this is just constructing a flag saying, hey, let's say the player's on layer 1, 10, and 16. Those bits are set. See, and you can see the value is 1. In the second bit, the value is 2, 4, 8, 16, 32. You've already seen all that, right? That was our flags. Where is this? That was our little Boolean flags right here, storing up to 32 collision information. And so the mask is just what you're going to compare to see, hey, have you collided? Look at this. Well, the mask on 1 is set and 1 is set here, so a collision occurred because that's our mask, and our mask is looking at that same bit. But let's say we don't have that set and we have 6 set. Well, the mask is setting bit 5, which is value 32, and it's going to compare it with this layer. And if those two are 0, you don't have a collision. And so that's where you've already seen bit masking working in the collision setting. So when Godot's engine goes through the collisions, it's just doing a bitwise comparison, looking at the various flags. This is on layer 1, 10, 16, 24, and 32, and it's going to say, hey, I've got 6, 10, 16. Oh, hey, look, these 2 bits are set. That's going to return a true. There was a collision. By comparing, going through the masks and seeing, is it going to return a 0 or is it going to return a 1 based on the masks? All right, well, I hope that was helpful. I hope, happy bit flagging. Let me know if you have any questions or if this was helpful or not helpful or way too pedantic. I know it was quite a long video, but I hope that kind of gives you a sense of how to use these in your project with being both able to combine settings and run through them, but also not breaking your API. Because look, we didn't have to modify this take damage function's signature at all, right? We didn't have to modify it at all when we started adding further damage types. All right, you can use them in tons of other operations. You'll see them all over programming. So I hope this was helpful. Take care.